So we've been building up to our memory agent. We talked about the concept of long-term memory. We talked about using the line graph store to save long-term memories. We just showed how to save memories as a single structured object profile. Now let's just extend that a little bit to also talk about memory collections. Remember, we talked about profiles and collections, profile being a single representation of, for example, a user that you save as a memory, a collection being a collection of different memories that you can propagate and update. So just like before, we'll go ahead and use line graph here. So just like before, we'll go ahead and set our LangSmith API key. Let's talk a little bit about collection schemas. So we introduced this a bit previously, but sometimes we want a flexible collection to store information over time and allow it to grow. So for example, go all the way back to our kind of motivating agent example. We're going to build a to-do list application or agent, and we want items in the to-do list to kind of grow over time. Now, alternatively, we also want to maintain like a user profile, for example, like information about a user, and that's a single representation, and we just talked about that previously. That is kind of continuously held and updated. Collections are very useful for cases where we want kind of open-ended addition of new memories over time. So let's consider a simple schema for memories. Here's an example of like a memory. It just contains some content. And a collection is just a list of memory objects. We can use with structured output to produce outputs that adhere to this schema. So let's go ahead and try that out. Invoke our model with structured output, pass in a message. And cool, we get two memory objects out. One is my name's Lance. The second is I like to bike. Cool. And those are both Pydantic models, just like we saw here. We can get one from our collection, dump it to addict. Cool, we saw that before. And of course we can save each of those to the store. Now here what's a little bit interesting. Remember before we saved to the store, namespace, key, value. Before when we had a single profile as our memory, the key was always the same. We just overwrote every time. Now here we're saving different memories, and so we want a collection of different keys. And in this case, we'll just have each being a unique UUID. So there we go. And we can just use search to get them all per our namespace, and we can print them out. There we go. You can see the value is just the dict that we're storing, the namespace, and some metadata. Now, when it comes to updating, the same challenges we saw previously also apply. For example, each memory in our collection could have a complicated schema. We need the ability to update any given memory, even if the schema is complicated. That's the same challenge we had with a single profile. That motivated use of trust call. So we talked about trust calls being a very nice way to both generate complex schemas and update them. The intuition underneath trust call was use of JSON patches and validation to check that the extracted object actually meets the provided schema. If it fails validation, trust call will attempt to JSON patch in corrections, and we'll do kind of a patch and validation loop until validation passes. Now what's really neat is trust call also enables the ability to create a list or collection of memories. All we do is just provide this enable inserts. So what's going to happen here is we can basically allow trust call to update elements in a list or add new elements to the list. So it has that flexibility. So just as we did before, we create a trust call extractor, we provide the memory schema to it, and we just flag enable inserts to be true. So let's kick this off. We'll provide some basic instruction, extract memories. We'll provide a conversation just like before, run that. And we can look at the output. Here's a tool call. So it extracts basically a memory that adheres to our schema, which is just very simple. It's just basically a content field. And we can see here is the resulting object. I had a nice bike ride. Cool. Metadata is just the tool call in this particular case. And also update the conversation. I had a little bit more detail about what I did after my ride. I ate a croissant, and then I also, provide some reflection about what I've been thinking about. I provide this. So updated instructions and my existing memories. Okay, you can see the existing memories are supplied as a tuple with an ID, the tool name, memory, and just the memory itself as, for example, a dict. Here we go, right there. Invoke the extractor with the updated conversation and the existing memories. Cool. Runs. And nice. We can see now there's two different tool calls out. And we can look at the responses. Cool. So it looks like one is kind of updating my initial memory about the bike ride with some additional information about what I did. And it also stores that I ate a croissant at Tartine, and I'm thinking about a trip to Japan as an independent, separate memory. Now what's cool here is you can also see in the metadata now, it amended the initial memory. You can see by this JSON doc ID identifies the memory that is being amended by this tool call with new information, and it creates a new memory, which is noted as this kind of new tool call. So that's the way to think about this. Basically, you're running the extractor, providing a list of existing documents to it, and basically the tool calls will update any existing documents and insert new ones. That's really it. It's very simple. So this is really nice for working with collection schemas because it allows us to pass an existing collection and basically use tool calling to update elements in the list and add new elements to the list, all done for us. So again, I'm just going to add this to my chatbot now. Here's my memory schema, just like we defined above. Here is our trust call extractor, just like we defined above. And this is actually the same as we saw before. We have some chatbot instruction that's going to load any existing memories. Now we're just going to have the trust call instruction, which is going to match what we saw previously. Now you can modify these instructions accordingly, but in this particular case, we'll keep it fairly simple. Now really the only differences from what we saw with the profile is that I'm just going to call store.search with the namespace to pull out all of my memories as a list, and I'll format them accordingly here. I'll pass them into the prompt just like this. So it's very similar. Only minor differences: before we're using get to extract a single memory object. Now we're using search to get a list out. That's really it. Likewise, when we write memories, we just invoke our extractor. Just like we saw above, we pass in the existing memories, which we get right here from the store. That's it. Really simple. Format them as a tuple just like we saw above, with a key, a tool name, and the dict itself. Now here's where the magic of trust call is quite useful. Remember, we're saving each memory to the namespace. The namespace in this case is just memories and user ID, so that's unchanged, but each memory has some key, okay? Now that key is going to be just a UUID if it's a new memory, but if the trust call extractor provides a document ID in the response metadata, then we know that we want to update an existing memory, so we're just going to overwrite per that doc ID. That's really it. Now remember, how does that JSON doc ID get provided? Well, when we provide trust call with existing memories, we're providing it with the IDs right here. That ID we provide it with is just the key. So this is pretty nice. Let's walk through it logically. If we do it from scratch, we use the extractor. We have no memories in our store. We do extraction. Each memory has some UUID defined here, and we write it to the store. That's great. So then on a second time around, we get all the existing memories. The existing memories all have a unique UUID as the key here. We provide them to trust call as tuples. Trust call makes the decision to update any existing memories, and it retains that UUID of the memory. So what's really cool is, if it decides to update an existing memory, that UUID is present here in this JSON doc ID. We get it from the metadata, and we just write that back to the store with the corresponding doc ID. That's it. So that's how we can update existing memories really nicely in the LangGraph store. Now let's go ahead and create a graph here. There we go. This is the same flow we've seen before. Let's go and kick it off. Hi, my name's Lance. So the functionality here won't look very different. I like to bike around San Francisco. Cool. We can look at the memories we've written here. So, basically it has a memory I'm Lance. It has a memory I like to bike around San Francisco. And again, you can really tune the way, or kind of the rules by which it writes memories in that system prompt and in the schema. But this is like a very simple example where the schema is just content and then like some information about the memory. And again, I'll just continue the conversation. Bakeries. Now, let's say I create a new thread, same user. What bakeries do you recommend? Same deal as before. Cool. It recommends a bunch of bakeries in San Francisco because it's pulled that from memories. Now let's look at this a bit in Studio quickly just to explore a bit more about what those memories look like when they're saved to the store. So we're in Studio. We open up Chatbot Memory Collection. And I interact with it. And I give it something that I did. Right. Takes care of memory writing. I also went biking in Marin Headlands. Cool. And it's conversing with me as normal, and it's also doing this memory writing. I can see that memory node being called. This null just means that the node itself, like it's not returning anything to the user. That's fine. Now I can open up a new thread. I can ask what bakery do you suggest after biking? Call model. Cool. And it suggests a bunch of SF bakeries because it has those in memory. Pretty nice. We can look at memories here, and now we can see instead of a single profile, there's a list, and each memory just has different information about what I did. Those are, of course, pulled into context to answer the question. We can open up the run in Langsmith, and we can see in the model call, go to Chat OpenAI, and we can see existing memories are loaded right here. So pretty nice. And that's exactly why it's able to condition the response according to my individualized preferences. So we're building up pretty nicely to our memory agent. We initially talked about general concepts for memory. We talked about using a LangGraph store with a simple chatbot. We amended the chatbot with a structured schema for a user profile, and now we amended it to include a schema for a memory collection. We can bring this all together into our agent.